Why is sampling from VAE latent space crucial? Imagine you have a magic box that can create new images or sounds just by picking different hidden settings. This is what happens inside a variational autoencoder. Instead of copying data exactly, it learns a way to generate new data that looks similar but is fresh and unique. In the world of deep learning and specialized artificial intelligence, variational autoencoders are a special kind of model that encode data into a compressed form called the latent space. This space is like a map where each point represents a possible version of the data. But here's the key. This map isn't just a fixed point. It's a probability distribution, meaning the model learns the likelihood of different features being present. Sampling from this latent space means choosing points based on these learned probabilities. Instead of just copying what it saw during training, the model can pick different points and decode them into new, original outputs. This ability to generate new data is what makes variational autoencoders so useful for creating art, music, or even realistic images. Think about it like this. If you want to create many different images of cats, you don't want to just copy one cat over and over. Instead, you want to explore the space of all possible cats. Sampling from the latent space allows the model to do just that. It can produce a variety of cats with different fur colors, shapes, and expressions, all while still looking like cats. The reason this sampling is so important is because it turns the VAE from a simple data compressor into a creative generator. It can smoothly interpolate between different data points, meaning it can create a transition from one image to another. This is useful for animations or designing new products. In practical terms, the model learns the mean and standard deviation for each feature during training. When it samples, it picks a point from the probability distribution defined by these parameters. The decoder then takes this point and turns it into a new image or sound. This process balances the accuracy of recreating known data with the ability to produce something new. Using smart sampling methods like importance sampling helps the model focus on the most probable areas of the latent space. This improves the quality of the generated outputs without requiring excessive computing power. Sampling from the latent space also helps in applications like image synthesis, text generation, and even creating virtual environments. It allows the AI to produce diverse outputs that share common traits but are not identical. Understanding this process is important because it shows how models like DALL-E or Midjourney can generate new images from simple prompts. It also raises questions about originality and ownership when AI creates new content. In the end, sampling from the latent space is what makes variational autoencoders powerful tools for creating new, varied, and interesting data. It's the secret behind many of today's most exciting generative AI applications.